and welcome to I'm Chrono Cross's first low effort, one take, one of a kind YouTube video. Let's go, let's play something. Oh, not that. Oh, God. Alright, I'm failing at this one take thing. How do I stop the meowing? That was bad. Sorry about that if I jump scared you. My name is Chrono Cross. I've been teaching myself software development, full stack developer. I started with Ruby on Rails. Then I went to the Mern stack, then the Gem stack, and now I'm everywhere you can possibly be. I'm lost in the sauce along with all the other developers out there. But I'm going to try to keep this entertaining and keep talking to keep you entertaining, because programming can be very slow to learn and very overly abstracted and confusing, and you got to think of every step of the process. So yeah, bear with me. 34 years old. I think I'm confident enough to now start putting myself out there to first help teach others that want to do what I'm doing, become a full-time developer, or just a hobbyist. I don't need to be paid. I mean, I'm about 4.5 years in to self-taught, and I've still not applied to one job. But I'm finally getting to the point where I'm comfortable enough to put myself out there. So here I am, one take. And I'm probably setting a first bad impression. I'm not good with impressions. The first impressions especially, I'm bad at them. But all right, here we go. The problem is, given the head of a sorted linked list, delete all duplicates such that each element appears only once. Return the linked list sorted as well. If you don't know what a linked list is, I suggest not really ready for this video, but I'll try my best to give you a high-level explanation with a little low-level detail. So a linked list is a data structure that's used in programming. And it don't matter what programming language you're using, a linked list is viable. But you're not really going to use them on the day job. It's mainly for interviews. But you can use them in real-world applications too. One example would be kind of how the file system works in Windows, except this would be more like a binary tree or an n-ary tree. So you could think of each folder as a node that has children under. Oops, that's not a folder. All right, no fancy. Oh no, to my video. I'm failing. Stop it.
No, God, please, no, no.
All right, let's just go back. All right. So, oh my God, I'll make myself look stupid. Here's a way to picture it. Each node has a pointer to another node. And that node points to another node. And that node points to another node. And that node points to another node until you hit the last node. And to know you're at the last node, it will be null. So the last node will point to null. That's how you know you're at the end of a linked list. Each node is a thing called an object that points to other node objects. So you could think of it as node instead of object, because we're in an abstraction world where programming's just, that's not nude, that's node. Thank you very much. So this, what I'm showing you right here, is the exact same thing as this. Except if you look at this, you see an array, don't you? But that's an abstraction. This is this, which is this. Which ain't this. It's actually like, how do I explain this? Class, linked list, which will have this dot head equals null. And then you would say, like, I don't even know if that's right, to be honest with you. Let me Google it so I make sure how to set up basic linked list JavaScript. I just want to show y'all real quick. Right here. Which ignore the length and the tail. Well, no, I guess this is technically right. But to make it simple, get rid of the length and the tail. Don't worry about that. Just pretend the linked list has a this.head equals null. And then each node's one of these. They have two properties, a value which points to the actual int or whatever is being represented in that node. And this.next is just pointing to another one of these with its own value that's pointing to another one of these until one hits null. Right? So when you think of the .next is this. Even though we're on this node, if we say node.next, it's going to be this, which is going to be the next node it's pointing to. And etc., etc., etc. So this is node.vals 1. Node.next is a pointer referencing the next node in the linked list. Alright, I hope, 6 minutes. Alright. We're going to solve it using recursion. That's the catch. And recursion itself is hard to learn, so I'm going to do my best. So the first thing we need to do is our base case in recursion, which is when do we stop calling ourselves? So recursion is when a function calls itself over and over. All right, so it's like a function using itself to solve itself. It's kind of like if I pull this up and then you start seeing all these little pictures that go in here. That's recursion. I guess you could say. But yeah, in programming, if node, or actually head in this context, we'll just say head. Actually, let's make it node to make it simpler to understand. Don't worry about the TypeScript stuff. We'll try to make this as simple as possible. So if node equals null, that's our base case, we're just going to return null. And until we hit our base case, we're going to keep updating our next pointer to the next node. But we're going to do it recursively. So we're going to say node.next equals delete duplicates. And then we're going to pass the next one in until we hit null. Then once we hit null, we got to think recursively. So let me try to mental model this. We're going to call delete nodes. All right. This is a stack. Stack means last in, first out. Liposuction, baby. No, I'm just kidding. But all right. So we're going to take the first function call, and we're essentially passing passing the first node in the list that's pointing to all the other nodes. So, but to make this simple, we're technically passing 112 in, but let's just make it simple and we'll just worry about the val to abstract it a little more to not overwhelm you watching me, which you may be an experienced dev. And if I'm saying something wrong, please correct me, which there's probably quite a bit of things I'm saying wrong here and there, but it's not on purpose. And I will correct myself. And this is a working solution. I fully understand it. And so I don't know why I'm defending myself. But we're just going to do the value. So we're going to call delete duplicates 1. All right. So when 1 gets passed into here, we're going to go back up and we're going to check, is 1 null? No. So then we're going to do node.next, and then we're going to pass another 1 in. So basically, we call it again with 1. You get where we're going? Then we're going to check, is 1, 1? Well, 1 that's pointing to 1, is it null? No. So then we're going to set its next pointer to the next one, which is 2. So we're going to do this again, but now it's with 2. And we're going to try to do it again, right? But we're at the end of the linked list. So when we pass next in and we check node, wait, let me make sure I'm explaining that part right. We pass 2 in. Then when we pass 2 in, it's going to try to set node.next to null, and then it's going to check node, and node's going to be null, so it's going to return null. So that's when we hit our base case. So when you hit your base case, this will actually turn into null. But we ain't there yet. So that's the winding phase. Once you get to the winding phase where we hit null, so I should have probably just illustrated. So when we hit null, that's our base case. So we don't do anything. We pop that off the stack. And now, since we're popping it off the stack, we're going to pass null here. But I still need to write more code. Once we hit the base case, that's when the magic happens. This is an unwinding recursion problem. Meaning after we hit the base case, we're going to start applying the logic. So now we're going to return if there first is a head.next, and we're going to check if our node.val equals node.next.val. Because remember, the essence of the problem was we got to get rid of duplicates. When I say node.val, we're actually checking the values, not the objects or referencing the objects, right? And if they're equal, and there is a head.next, we're going to return head.next. Otherwise, we're going to return head. That's why we do the head.next check, which I'm about to stack trace this for you. And that's it. That's the solution. Does it make sense to you? Even with all my explanation, it probably still don't make a lick of sense. But it might. I'm making a lot of assumptions here. It could be anyone watching this video. Alright, let's make sure. I hope I didn't get no typos. Cannot find name head. I do that every time. So it's not head. I hope y'all caught that. You probably caught it when I started it, I hope. But it's all node. Remember, we changed the node. It was head, then we changed it to node to try to make it more easy to understand. So it's all nodes. And that's it. Now let's submit it, make sure it works on everything. Boom. There you go. Now the memory is high because I used recursion. Iteratively is probably a better approach for this problem, but recursion is a really hard concept to understand, so I thought that would be my first video because it even took me a while to solve this recursively. Like, yeah, I was wanting to beat my head against the wall because it's an easy problem. I've been programming years, you know. But yeah, I think I've solved this problem just about every way you can solve it. So, all right. So let's try to trace through it. 1, 1, 2, which is an abstraction. It's not actually an array. This is a linked list. It's just an abstracted way to look at the values. Remember, this points to this and points to this, and then this points to 2 and null, and then 2 points to null. So they're all essentially objects pointing to each other. All right. Here comes the fun part. So first we're going to call it with the whole tree passed in, 1, 1, 2. All right. And we're going to check if node equals null. Node's an object, so it does not equal null. So this is going to be skipped. Then we're going to set the current node dot next to itself, but we're going to pass the next node in. So technically, the next node would be 1, 2. But for simplicity's sake, we're just going to say 1. So we're basically going to pass 1 here, which is pointing to 2 or 1, and then oh my Jesus. Pointing to 1, pointing to 2. And then when we pass this in, we're going to check, does this equal null? It doesn't. So then we're going to set node.next to the next one, which would be 1, again, here, 1, 2, but we're going to keep it simple and just think about the value. So it's going to be 1. So then we're going to check is 1 null, which one, remember 1's pointing to 2, 2's pointing to null. That's not going to be null. So then we're going to pass the next one in. And then we're going to check, does that equal null? It's not. But that next, then we're going to try to set node.next to equal node.next. And that node.next is null. Now this is when our base case is hit. If null equals null, return null. So now this part, just think of it this way. Now we can finally, we hit our base case. So that means all these are on top of the stack. But now we're taking them off and actually plugging the values in. So another way you can think of it is, okay, now we're going to node.next equals null. I don't know why that deleted. But yeah, so now we're going to start popping them off the stack one by one with the values that we previously fed into them. That's the part that's hard to mental model. Because now we're going to go backwards, but node.next is still, so when we're here, node.next is still referring to this one, even though we're moving backwards. Node.next is still forward front facing, but we're going through it backwards, which can make it confusing. So then we're going to check node.next, which is going to be null. So since that's null, null is false in JavaScript. This is going to evaluate to false. And we're going to return the node. Well, if you remember, the actual node is 2 that points to null. But to make it simple, we're just going to do the value. So it's going to be 2. Oops. I meant to hit that one again.
Please, no! No!
But yeah. So then we check, is there node.next 2, which is pointing to 1, which is an object, which is true. And then we're going to check, does 2 equal null? No. So we're going to return the node, which in the context of this call stack would be 2 that's pointing to null, and now 1 that's pointing to 2. 2 pointing to null. But for simplicity's sake, we'll just think of node.val. This is node.next. That's what it's actually pointing to, which is actually the memory address of the node that's pointing to these other nodes. But let's not over confuse it. But I am trying to, if you made it this far, I hope it's clicking some. All right, now that we're here, node.next, we check if that's null or if it's just exists, true. And we're going to check, does 1 equal 2? No. So we're going to return the node. So now it's going to be 1 that's pointing to 1, that's pointing to 2, that's pointing to null. But we only care about this 1. So if we do node.val, it's going to be 1. If we do node.next.val, it's going to be 1. I'm pointing that out. So remember, this is the node.val. This is the entirety of the node right now. And this is the node.next. And remember, node.next.val is just the actual value of that object. Confusing, I know. But now we're going to check, does node.next, yes, there's a node.next. So that's going to evaluate to true. And then we're going to check, does node.val 1 equal node.next.val, which is 1, true. So this is the first time where we're actually going to just return the node. So if we just return the node, oh, no. Oh my God, I just messed it up. This is the first time that's evaluated true, so we're going to return node.next. My bad, I really about messed y'all up. I hope you caught that before I caught it. If you did, I think you're pretty good with your recursion, brother. I see you. If you did catch that, say something down bottom. Say like Sam Altman's the devil. No, I'm just kidding. I don't know if I trust the guy though. But yeah, so we're going to return node.next, which is basically going to get rid of this. Because remember, the node's one that's pointing to 1, that's pointing to 2, that's pointing to null. And the node.next is the one that's pointing to 2, that's pointing to null. So we're just going to return this, and that's our final solution. But it's mutating it, so we don't actually have to return anything. So now remember, this is abstracted away. So essentially, the solution is that. I was just showing you what was happening under the hood, the parts you can't see. Now I could make a video animation of how it's working. If you're interested in that, just let me know below. I hope you enjoyed the content. I hope you learned something. If you have any questions, hit the comments below. If I messed up anything besides the mistakes I found out were a mistake, you know what I mean? Like, if there's something you could point out to help me, comments below. Till then, the name is not the Primogen. No, I'm just kidding. I ain't going to copy his thing. I'll think of something. And my future videos, like I said, are going to be more effort. I just needed to start, and I hope I don't have to take this video down because it does so horrible. But at the end of the day, I'm still learning, so it's a win-win. And it's a win-win-win if you like the video, I learned something, and you learned something. Ooh, that's a pretty good catchphrase. All right, peace out, world.